Hi everyone, on behalf of the Southeast New England Program Network, welcome to our training on maintaining green stormwater infrastructure brought to you by the Providence Stormwater Innovation Center. My name is Leah Soloway from the New England Environmental Finance Center, and I'll be assisting with logistics for today's program, along with my colleague Tess Clark from the Syracuse University Environmental Finance Center. Today, we will be joined by a great team of stormwater experts, but before we introduce them, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. You'll be able to ask questions by typing them into the questions box on your GoToWebinar control panel. We look forward to answering questions, so please type them in at any time. Additionally, you can request a certificate of attendance for joining this webinar. Information on how to do so will be available on our follow-up email after the webinar. Now for a little bit about the SNEP network. Here you can see a map of the Southeast New England Program region. The SNEP network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through the management of stormwater and restoration projects. We focus on building local capacity by providing no-cost trainings, webinars, and technical assistance to communities in the SNEP region. If you want to learn more, please visit our website, snepnetwork.org, for more information. And on that note, I'd like to hand things over to Ryan Kopp, Stormwater Coordinator with the Audubon Society of Rhode Island. And with that, Ryan, please take it away.
Okay, thanks Tess and Leah and the SNEP Network for all your help with technical assistance and help with promoting this training. It is really very much appreciated. My name is Ryan Kopp. I'm a coordinator at the Providence Stormwater Innovation Center, which is based in Roger Williams Park in Providence, where the city has installed over 40 green stormwater structures. The center uses these projects to demonstrate to communities throughout Rhode Island and New England different strategies for improving urban water quality through the use of green infrastructure. So we provide trainings related to the design, construction, and maintenance of various stormwater management practices. So in a normal year, this training would be taking place in the park, out in the field, and everybody would be able to take a look at all the different BMPs that are available in the park. So hopefully that's coming soon, and maybe by fall we'll have those in-person trainings again. A secondary piece of our mission is to educate the community and the public about stormwater and green infrastructure through different volunteer monitoring programs, neighborhood outreach programs, festivals, and workshops. So thank you everyone for attending today's training on maintenance of green infrastructure. And without further ado, we will get to our presenters. Jamie Houle, he's the program director for the University of New Hampshire Stormwater Center. Brian Burns, the deputy superintendent of the Providence Parks Department. Scott Wheeler, superintendent of Parks, Grounds, and Forestry, the city of Newport. Steve Ricci, director of field operations, Groundwork, Rhode Island. Jacob Gorky, river ranger with the Woonasquatucket River Watershed Council. Eric Beck, administrator of groundwater and wetlands protection with the Rhode Island Department of Environmental Management. And if you do want to find out more about these presenters, great presenters, there's a link at the top of this slide with their full bios. So for the training today, we did actually come up with more content than we could fit into 2 hours. So at the end of the webinar, there will be, if you have time and your schedule allows, Brian Burns will be giving a short talk about tracking maintenance with various software programs. So with that, I will hand it over to Jamie Houle.
All right, thanks, Ryan. And you're either seeing my PowerPoint or you're seeing my kids. Hopefully you're seeing my PowerPoint, right? Good, good.
You can see your PowerPoint.
All right. Great. Well, thank you very much. I'm going to kick things off and just give a general introduction to this very important topic. One of the things I was confused with early on is just the plethora of names out there, and there's some creative names of different systems. Sorry, this is supposed to be animated. You know, and the names don't necessarily portray their function or the maintenance burden. Their names. Interestingly, all BMPs have a certain anatomy, and it consistent across the range of different devices, regardless of what they're named, regardless of what their primary function is. They all have some type of sizing that often is dictated either by the manufacturer, the engineer, or the local guidelines, and it has an inlet, some type of pretreatment that would facilitate maintenance, short-term maintenance, and then an outlet. And then there's an in-between. So we work with a contractor pretty readily over the last 20 years, and our first conversation is always something around, all right, it has a gazinta, a gazada, and an in-between. And it's just kind of funny because he broke it down into these elements. We know we have to talk about the inlet and that configuration and how it's constructed. We know we have to talk about the outlet, and we know there's an in-between that's largely engineered. But I think the metaphor is useful for looking at maintenance because, for the most part, this is about the level of that we're going to really embrace these systems. So the in-between varies, and it's often flexible based on, I would say, either regulatory guidance or preferences of the owner operator, the long-term owner operator. And this is one of those areas that we hope continues to grow, because I think traditionally the preferences, particularly the maintenance preferences of the owner operator, the long-term owner operator has, for the most part, have not been incorporated into a lot of design. And hopefully that's changing as we embrace maintenance and the need for maintenance. So early on, every system that was designed had an operation and maintenance plan. Typically, it was 30 or more pages. And my guess is that no one or very few people outside of the primary authors of that document ever read it or interacted with it. And so that has been changing over time. What you have here is two examples of some of our checklists. One of our early checklists, we reduced those 30 pages to 1 page and 4 primary items. And through work that we did with Warwick, we tried to reduce that even further, so that you can see on the right. And really, we're looking at visual indicators for the most part. Can water get in? Can water get out? Is there any evidence in the in-between that there's some type of problem? And so those who do routinely do maintenance, this level of insight or oversight, it can be minimal. Like a trained eye can validate and verify this relatively quickly. And so hopefully that's where we're moving towards over time. When we look at maintenance, the actual function can be broke down, I guess, into some categories. There hasn't been a ton of literature on green infrastructure maintenance. This is something we presented in a paper that was published in 2013. Unfortunately, that's still very relevant today, at least some of the guidance and the background. So we use these types of categories to portray the types of maintenance that we're anticipating and the level of, I guess, the cost, the prospective cost that might be associated. So something that minimal or simple would be, mowing the lawn, very routine operations that don't require engineering, I guess, all the way up to complicated. Now, these take into, I guess, greater detail when we look at the types of maintenance cycles that are out there. And here we're seeing maintenance cycles in a decreasing order of cost. So the more costly, but I think it's also in an order of what we generally see out there. So for the most part, reactive maintenance cycles dominate the industry. And what I mean by a reactive maintenance cycle is, in general, you're ignoring the systems until there's evidence of a problem. And when there's evidence of problem, it's probably well past the need for maintenance. And this I guess we would categorize as probably the most expensive. So in the short term, it's very cheap. In the long term, it's not as effective for water quality and performance. And in the long term, if your system fails, then you're engaging more skilled and more engineered approaches to fixing and repairing that. That down to predictive or periodic, our feeling is that within 3 years of operation, and some of the later speakers hopefully will verify or validate this, within 3 years of most systems, you get a sense of the full range, the universe of types of approaches that you're going to be having to implement or schedule in order to maintain these systems. To proactive, and this would be more around structures that might be underground and might not be as visually easy to inspect, but you would be doing some proactive things to ensure that there's no failure, like inspections and maybe sweeping or cleaning. So just some general ideas of what those activities are. Periodic predictive would be, you're going to have to remove solids, particularly from the pretreatment area. That pretreatment area should be designed so that you have easy and frequent access to it, and you're removing the coarse materials more frequently than maintenance activities that you're doing within the system itself. Inspection, mowing, or vegetation pruning or removal. Proactive would be like street cleaning, a very proactive source control that can limit the amount of debris available for mobilization into your system. Erosion and sediment control, routine seeding and revegetation in areas that maybe look like they're struggling. And when you look at costs, we developed some idea of costs based on the level of complexity. And again, the idea here, if you have cost on the vertical axis, and then these are the various systems on the horizontal axis, from ponds, retention ponds, detention ponds, swales. These are more conventional style systems, to now getting into the green infrastructure. What we see is, provided the pill we have to swallow here is that we're doing maintenance. And so if you're not doing maintenance, obviously you can't compare those costs to anything else. But if you are doing maintenance, a lot of times some of these conventional systems are on a scale or in some cases higher in annual cost than green infrastructure. That said, it's likely that the maintenance activities are different. So it's something we have to consider as we move towards green stormwater infrastructure for water quality. Now, I don't generally like cost because they're always subjective. And so what we've done is, in this 2016 memo that EPA Region 1 has released, we actually have predictions of maintenance and annual maintenance expenditure in hours. So there are ways to assess the man hours or person hours that you'll be dedicating to these potential systems over time. And this is really important because as we, again, move into more life cycle analysis, again, this is our chart from our 2013 paper, and I just want to focus you on one thing. And this was something where the annualized or amortized annual maintenance costs intersected the capital costs of the system. And I thought this was a really interesting ratio because, if we take a design life of 15 to 20 years of these systems, what we see here is if you're within that ballpark, your system should be evaluated based on the capital costs, which invariably that's what happens. We say, we want the cheapest system. But if we're considering maintenance, then we need to consider that long-term maintenance cycle. And then if you're looking at things like ponds that might be relatively cheap from a capital cost, but incur larger annual maintenance expenditures, if in 5.4 years my cumulative maintenance costs now equal my capital costs of the system, then by the anticipated life cycle, I will have paid for the system 4 or 5 times over with respect to the maintenance burden that it initiates. So it's something I think to consider, especially as we move into this direction and you're the owner operator and someone's presenting something for your facility that you're going to own and operate for 20 years or more. You want to be cognizant of what these costs and these associated labor hours entail for your organization. And I want to end really quickly with one of my favorite anecdotes and stories, because this was a true turning point in my tenure, and just underscores the need for maintenance. We were involved in a award-winning project back in 2010 that was associated with a combined sewer separation, and we've been essentially did this whole stormwater management down a street in a particular city. And we were invited back 8 years later to do monitoring, and we had done some initial monitoring that really showed that, you know, these biofilters and these tree filters that we had installed, at least within the first year, were doing great. It was lining up with all our anticipated performance expectations, and then, you know, we left, and then 8 years later we were invited back to test it to see how it was performing 8 years later. And so what we did is we separated it into 2 sub-watersheds. So our control watershed was an untreated, so straight out catch basin, curb, gutter, catch basin, outfall. And then our control, that was our control, and then our green stormwater design was, again, that award-winning treatment that had 4 or 5 different tree filters, sand filters, bioretention, and the like. And when we studied just the outfall, we didn't look at individual performance, but when we studied the outfall and we measured the pollutant load, and I'm showing this to you in a log plot, and this is milligrams, this is pounds per year. What we see basically is when we compared the green infrastructure, a award-winning site, to the unmanaged site, what we see is really the legacy of maintenance, or more in particular, the legacy of lack of maintenance. And so we see within 8 years, no statistical difference in the water quality from the drainage area. And here's sediment, here's nitrogen. Again, the green is the green street, the blue is the control. We really don't see much statistical difference in the quality of the water running off these systems. Now, early on, we had monitored some of these systems and they lined up with our performance expectation. But 8 years later, lack of maintenance, we see these systems basically reverting back to as if we hadn't done anything. And so that was really compelling, and I really think it underscores the need and, quite honestly, the importance of maintenance, even more so over type of system. So if you can ensure that you're going to maintain that system, I think that takes priority over the style of system that you're installing. So was this predictable? I would say at this point, yes, because we never discussed this with the long-term owner operators. We never asked them, one, if this is something that they would envision maintaining, or that they even had tools to maintain. And it turns out they had neither. And so hopefully, like I said in the beginning, this is something that is starting to turn around. We're involving the long-term owners and operators in the design process, such that we can ensure the sustainability of our investments. So with that, I will end and turn it back over to Ryan.
Okay, I think we're going to take like 30 seconds to do a poll, just to get an idea of some things that you encounter with your work. So if you can take 30 seconds to fill that out, that'd be helpful. And then after this, we will do a short or 5-minute question and answer, if you guys have any questions. So. Okay, I think that's probably good on the poll. Okay, yeah, so it looks like same as what I think we encounter a lot is clogged inlets, weeds, sediment. They're probably all an issue, but yeah, these are These polls are important to help us develop content for future trainings. So I do have a couple of questions here in the chat. This first one says, Jamie, do you have another similar study that compares a system that is well maintained versus a system that is not? I think you're on mute, Jamie.
Unfortunately, I don't. I mean, we have studies on maintenance. This particular study that I just showed you was the first time we ever really looked at the legacy of a maintenance program. And, you know, I would love to do more comparative assessments like that, because lost in here are the exact technical details of how these systems fail and when they fail. And, you know, so those are really legitimate questions that unfortunately we can't answer.
Okay. Got one more here. It says, is there any sort of real-time monitoring work being done, some sort of an alert system that would be accessible via the web to find out if systems were functioning properly? I'm assuming so that would trigger you to send out maintenance people. And
yep, there's no shortage of this Internet of Things approach, where you have different low-cost sensors that are embedded in your system that send out alerts, and that's all within the range of potential. My only reaction to that is, yes, it's possible, but you know, an alarm that I guess goes somewhere that's not, doesn't have the staff and doesn't have, you know, the equipment to maintain it is the real problem, you know. So there's no limit of what we can do with technology. Where I see the gap is having systems that fit our maintenance culture, and systems that, you know, are designed so that we don't need these types of things.
Okay, I think we have time for one more question here. It says, any thoughts on why the TN went up in the GI street as compared to the control? Is that just fuzzy data?
I would say it's within the realm of the inherent variability of the data. So I would just, it's just background variability.
Okay. Okay, I think we're going to keep going on. We will have a few other question and answer sessions throughout the webinar, so keep asking questions in the chat. But now we'll move on to Scott Wheeler with the City of Newport. And take it away, Scott.
Thank you, Ryan. Yes, so my name is Scott Wheeler. I'm the Superintendent of Parks, Grounds, and Forestry with the City of Newport. I've been with the city for over 26 years. I fall squarely into that category that Jamie was talking about as the maintainers of these systems, not necessarily in the past, the people involved in the design as much as I would have liked to have been. And everything I know about green infrastructure, I've really learned from Jamie. I'm going to give you a little bit of some examples of some projects in Newport. Newport, being an island community surrounded by bay and beaches, we care a tremendous amount about water quality and certainly have some issues. So when it was time to redo Broadway, our sort of main downtown street, we went in all the way with incorporating as much as we could as far as green infrastructure. And this is a long section of permeable pavers directly opposite our town hall. The interesting thing about this is, even though we have one of the largest contractors in the state doing this installation, they had never done a project similar to this. And the workers actually installing it were convinced that it wasn't going to function. They convinced all the abutting neighbors and shop owners that it wasn't going to work. And in the reality, it has worked. I will point out, just before I go from this slide, One of the things to look at this is you can see between the pavers and the asphalt, they felt there was a need for granite strips. And with dissimilar materials, there's always going to be movement. So if there's one thing I would change out front is I would have loved to have eliminated that granite, which is proving. So we did see a little bit of minor sedimentation, settling, and really nothing this many years out that is any concern. So what has turned out to be an absolute bane of our existence is cigarettes. No one saw this going in. It's a little bit like they took a cigarette out and said, gee, what space should I have these apart? Well, let's just use this as a spacing. And so just about every single complaint we've got about this green infrastructure on Broadway has to do with the massive numbers of cigarettes. And those suckers really do not want to come out. We've tried just about everything to do that. Steve Reese is going to talk in more detail about the maintenance of permeable pavers a little bit on, but just to say it's frustrating. The picture that's missing is the flamethrower I wanted to try. The next step is these permeable pavers leave into these tree wells, and these systems also, like the permeable pavers, have worked out incredibly well. But what wasn't anticipated, all of this decorative Boston Garden post and chain was not part of the original design. Within half an hour of this structure being open to the public, I had calls from the city manager's and mayor's office about the potential risk of people falling into this. There was absolutely nothing preventing pedestrians from falling into these, in a sense, bear traps. So I was out there within a half an hour with 2x4s, and making a makeshift enclosure. So it's functioned in many ways quite well. There is a continuation of having to keep litter and trash out of this system. But when we have a heavy rainfall, too heavy to be absorbed by the pavers, the overflow comes in here. So you'll notice that there's no green in this, and that's because what wasn't anticipated in the design is the infiltration is so fast, is that everything that was planted in there literally floated up and completely came out. And after about 4 or 5 times of trying to replant, these floated up plugs we gave up. The other thing is you really need to look closely at your location. In this case, where they wanted to put in this line of tree wells, tree pits, was already an existing avenue of trees that completely covered the area. But people designing green infrastructure don't think about trees needing sunlight. So we had to do some pretty heavy pruning and actually change the trees to be the matching trees just to basically provide the canopy. Going further down Broadway, we had, again, another large, the intent here is instead of a tree well, all the water that flows down Broadway and doesn't get taken up was supposed to flow into this large rain garden. But again, the designers didn't think about public safety. And so as a result, all of these very expensive bollards and chains were an aftermarket design. So, everything should have worked great. But one of the things I would really recommend when you're doing green infrastructure in an urban area is you better do your site investigation up front. You better find out what's underground, because this catch basin inlet was not supposed to be in this location. It was supposed to be about 2 feet to the left, right in this area here. And the intent was once the green infrastructure, the rain garden fills up, any excessive water that isn't drained would come back and be caught up by that catch basin. Unfortunately, I think you could grow cactus in this catch basin. We're going to have to come up with a solution, because after about a year, that's all of the sedimentation we've had, because the majority of the water is caught by that drain. We're going to be experimenting with a mat or something else to try to get more water into this system. So we also have some other similar case, a system just next door. This one is totally only fed by, rain and a little bit of sidewalk runoff. So again, you should look up when you're designing these systems, because this very expensive system falls directly under the rain shadow of these huge trees. So they won't last forever, but certainly this is the type of considerations when you're trying to put green infrastructure into a dense urban area. So I think it's a success story. When our visitor center was being, bus parking area was being redesigned, we had a demand from the public to go back to the drawing board and include green infrastructure. So the design for our transportation and visitor center completely changed. And we have an extensive system of green infrastructure. And we also have pavers there. I think in this case, they're a little bit closer together, so a few, but still my nemesis, cigarette butts. But this green infrastructure system is really a great place to study, because it involves such a range of different systems. In this lower corner, you can see this sort of black cover. That's actually the inlet. And this system is completely fed by piping underground from the adjacent structure's rain gutters. As far as a point of failure, certainly from a maintenance, ensuring that those gutters, the drains, all coming into that are properly maintained is going to be essential, and is certainly going to be one of those challenges. Much simpler design, one that I like, is just simply, have a break in the curb, and so that automatically drains into it. What I would counsel is that engineers love riprap, and they love nice big stone that it's impossible to run lawnmowers over. Oftentimes this riprap clogs up very easily, blocking infiltration, and in some cases it actually provides a perfect place for invasive plants to get established. So we've been experimenting with smaller and smaller stone. We found about 2-inch stone, about the size what they would use for railroad grading, lies flat, leaves flow in over it. It takes handles all of the erosion, but doesn't create material that can catch leaves or harbor invasive plants. Great innovative design is simply have a grate over the sidewalk. And this area, I guess Jamie would call a pre-treatment area. When Jamie was kind enough to do a training for myself and all of my staff on how to maintain this system, and we did it actually before it was done. And so we discovered that this whole pre-treatment area was basically a standing pond. And a little investigation, it turned out that the stone between the treatment area and the infiltration area, they decided to put black plastic under the stone. So it was an easy fix, and it worked out really well to have Jamie there. Although the contractor wasn't loved, the checklist was pretty accurate for the project. And if you look just to the side of the photo, this is really what my favorite way to infiltrate. This is basically the whole back of the bus parking lot is simply sloped in such a way with no curb. It just runs directly opposite off the sidewalk into this long pre-treatment area, and then flows into the infiltration area, which you can see is vegetated. So I want to talk a little bit about vegetation. Jake Gorky is going to talk a lot about planted versus seeded. This system, as designed, was incredibly elaborate. It called for 10,000 perennial plugs. You can see a little limit of gravel and stones that run throughout this. And this was all supposed to be a perennial garden. I pointed out to then visitor center that was going to maintain this system how are they going to weed 10,000 plugs? And I was able to convince them to change it to a seeded area. And we had received some complaints about how it looked, but I certainly think when you look at this, there's plenty of beauty within it. The reality is the design called for everything off about 3 feet off the sidewalk to be meadow. But within about a month, the visitor center staff and director determined that it was just unacceptable to have a wild meadow downtown. And not only have they cut this area and the area around the sign, they actually fully mowed the full infiltration areas, which is a challenge. Recently, the visitor center has moved out, and I have the pleasure of taking over all maintenance. So we're going to be testing the waters and trying to go back to allowing this to be in a more natural state. But it's certainly a huge problem as far as people's expectations about what a green infrastructure system should look like in an urban area. I also wanted to just mix in that, our downtown urban systems are pretty expensive to install and challenging to maintain. But our DPW, in partnership with Save the Bay, has done some far simpler projects. This one's at Rogers High School, and it really is just a matter of eliminating some curbing, causing some infiltration. I had about 20 emails back and forth with the superintendent about how we could maintain this area that was acceptable. I think it's beautiful. I love the look. Not everyone does. We did a little more landscaping around the sign and trimmed edges and made it more acceptable. But we've got a similar, we're just in the parking lots, we were able to simply divert the water from catch basins into these sunken areas instead of draining into catch basins. And I just always, from my wetlands ecology, it's the ecology drives the system. So the fact that we actually didn't plant cat nine-tails, but they're actually appearing in our parking lot of our high school, to me, is the ultimate sign of success. And lastly, I just want to touch base on, I think one of our biggest problems with municipal green infrastructure is that the concept really has become scaled up by looking at rain gardens and people thinking that the whole solution is to take the type of rain gardens that have been sold to individual property owners as the solution to connect to their drain pipes, but that's what we should be doing. Well, no city, town, even botanical garden has the resources to maintain a system like that. But with some public education, a system like this that actually provides, beyond the water infiltration, loads of ecological benefits, loads of pollinator and habitat, and developing the political will when people complain that we're going to have ticks or we're going to have rats, that not to be afraid of nature, but that this really can be a functional natural system within our urban center that can provide a tremendous amount of benefits. So no idea how I did on time, but that's my my presentation.
Okay, thank you, Scott, for that. I think we're going to go right into now Brian Burns with the Providence Parks Department, and then after he's done, then we'll have another poll question, or a poll question, and then a question and answer session after that. So take it away, Brian, whenever you are ready.
Thank you, Ryan. Do we have my PowerPoint on the screen?
Yep.
We do. Okay. Hi, everybody. Scott and Jamie, thank you very much for that. Every time I listen to you, I learn something more about stormwater, so that was very interesting. Thank you. My name is Brian Burns. I'm the Deputy Superintendent of Parks in the City of Providence. We have the Providence Stormwater Center here in Roger Williams Park, which is 435 acres, 100 of which is water. Those waters are impaired. So we are a bucolic and rolling green park in the middle of an urban area. So all around us is urban streets. Our park is highly used, and so what better place for a stormwater center than that? And so through a consent agreement with Rhode Island DEM, we embarked on building 40 plus stormwater BMPs in our park, and then tried to guide the design based on what our maintenance personnel were telling us and the engineers were telling us. So we own everything from the design to construction to maintenance of these facilities. So we have it all. And what we found is that proper stormwater retrofits, proper design follows collaborative, smart, and well thought out design and construction. And that leads to easy maintenance. So maintenance is a function, and aesthetics are connected to that function. So we have limited real estate in urban areas. So anytime we try to take water offline, we want to incorporate what we can for aesthetics. This picture is a tree filter. So, but they need to be maintained to function. So we can build all the structures we want, but if we don't maintain them, in the end, we're not getting cleaner water. But very important to consider the design and get input from your maintenance staff prior to finalizing those designs. You need to know your capabilities of your maintenance staff, the equipment that they have, a bunch of different things that lead to their ability and success in maintaining these things. So like Jamie talked about, there's 4 main elements to any BMP. It's an inlet, a pretreatment or sediment removal, the weirs, and then the contaminant removal. And we are, like Jamie, changing our nomenclature. Inlet doesn't really tell what it is. So we're going to call it a collector or something like that. And we're working on that now. And we're working with many of our consultants still. Obstructions and inlets, there's lots of forms. Most of them are easy to remove. My grandmother used to tell me by the inch, it's a cinch, by the mile, it takes a while. So that's what we've adopted here in Rogers Williams Park. So in its most basic sense, you can use an inlet structure, which you see on the left-hand side, or you can sheet flow off a roadway through riprap or any other type of material that you see on the right. And here, very easy. If it's done frequently, it's extremely easy to keep these inlets workable. Much like what Scott did, we developed a drain inlet through a sidewalk, because when it comes to a riprap scupper that comes off a curb cut, if there's a sidewalk, and again, real estate's limited here in the park, we need to provide a safe walking path. So we came up with this sidewalk drain, and we have what my guys affectionately call a plunger. So what they do is they have a tool that they made, and it actually, they plunge it through and get whatever debris in there to clear it. And this is a good example of what we were talking about before, where you may have an overflow inside your BMP. On the left-hand side, you'll see that we have an atrium grate. So all the water that flows into this BMP collects here, and any overflow goes through this atrium grate and out to the waterways. The one on the right, which is very similar, but slightly different, the overflow is here in this drain basin, which is directly adjacent to the structure. So moderate to low flow will come down, take a right-hand turn, go through that drain out inlet and into this BMP. Otherwise, the heavy flow will just continue to the drain basin that's in the street. And this is when you deal with your engineers and you're getting into designing these things, there's 2 schools of thought on that. One, put all the water through your BMP and let the overflow in the BMP take what you can't treat out. And then those that say don't put enough water to inundate that structure, let the street serve as the overflow. So we've been dealing quite a bit with that, and we have different versions of it. Lack of maintenance always leads to more work. So this, believe it or not, is a 24-inch manhole in a AutoZone parking lot here in Providence. And what you're looking at is a 10 by 10 timber that's about 10 feet long. So we asked our forestry department to come over and help us get the railroad tie out of the drain manhole, because we didn't know how to take a 10-foot long post and get it out of a 24-inch round hole. And this is about 50 feet down from the inlet from Mashpog Pond. So as you see, they have a chainsaw on the end of a pole. We cut it, we put a rope on it, and that's what came out. This was a costly operation. DPW was involved with their claw truck. My crews, it took us about 3 hours to do this. That is certainly easily avoidable by maintaining the trash grate on the inlet coming out of Mashpog Pond. You can have all sorts of obstructions. So this obstruction may be a little more difficult to deal with. We had a stormwater art festival here in the park, and one of our attendees decided to set up right in the inlet, but we dealt with it, and everything was fine. Investments in stormwater maintenance here in Providence, DPW went out and bought a $200,000 vac truck. Not everybody has that ability, and for the most part, the BMPs in the park, 40 plus, are maintained by parks personnel. We don't have to utilize this piece of equipment because of the designs that we've done. And here we go. So the pre-treatment or the sediment removal. There is a vulgarity in the Providence Parks Department, and it is river rock. We early on, actually, I've been with the Parks Department for 6 years. Before that, I was a contractor for 30 years. I had built over 200 stormwater BMPs, and I had seen a lot of river rock. And here is relatively closely from the installation of that on the left-hand side. The right-hand side is what it looked like probably about 2 to 3 years later. So I actually came to the Parks Department in the middle of this transition. So if you can imagine what it takes to remove the sediment from this 18 inches of river rock, it's a very successful design in removing sediment. It removes it tremendously. But you don't see it until a foot or more of sediment has built up in it. So I brought my crews out here. They were new to me. I was new to them. I said, so we're going to take every single one of these rocks out. We're going to wipe them off to get the sediment off. We're going to pull all the sediment out. We're going to put them all back in, and then this thing's going to function again. When I turned around, all the crews were gone. So this is just too much work for them to do. So we leave this in place as a training tool only, but we will never use river rock in this sense ever again. If it's a small section right off a scupper off a roadway, that's easy to maintain. This is about 300 feet long, and it is a bear for us to maintain. So river rock is not something we use. But again, when you look at it, it's beautiful. So this is one of those areas where we will use it. It's very small. We can take care of it. It's in a highly visible area of the park. This is a sand filter, and this is the inlet. So very effective in sediment removal, very difficult to maintain. Here's another one. So again, this was a walking area, and this just doesn't work on the left-hand side. When you put the riprap in, you can't walk over it. So we had to remove the sidewalk in this area. As you can see, the handicap striping is still there. So this no longer functions as a handicap ramp. And on the right-hand side, you'll see the same thing that we did further down, farther away from the curb. It's less expensive when you install it, but like Jamie referenced, it's much more difficult to maintain. So what did we do? We switched to a different material. On the left-hand side, we installed exposed aggregate concrete. That means that it's a concrete walkway that you power wash off the top, and it provides a bumpy type of element. We also incorporated a 6-inch vertical drop. So when the water comes in, it drops down and the sediment drops out and maintains itself in that exposed aggregate paving. To the right-hand side, you'll see we did permeable pavers. In both pictures, you'll see that these are less than 10 to 15 feet off the roadway. And for lack of a better term, my crews utilize a drive-by sediment removal technique. They drive by, do not need to leave the seat of their truck to see if sediment has started to accumulate in these areas. So I think Steve Ritchie's going to talk later in the program about maintaining permeable pavers. I would suggest that what Steve's going to talk to you about are much larger permeable paver areas that have high vehicular and pedestrian traffic. Ours do not. So our maintenance of the paver on the right-hand side is a power broom, which is a glorified trimmer with a broom on it. In between the joints of the permeable pavers is rice stone, which is a 1/4-inch stone. About 1/2 inch of that 1/4-inch stone comes out when we power wash it. It is usually covered in sediment. That's our sediment removal. We will have a couple bags of rice stone. We'll broadcast it back over, sweep it back in, and then this is functioning again. Very simple, very easy for our workers to do. And versus a river rock where this can be 12 inches of sediment that has built up before you even know there's a problem. This will tell you and show you the first 1/4 of an inch or 1/2 inch. You'll see that it's there. So this has been effective for us in maintaining our systems. It is more expensive at the installation, but the long run effect of it, it's less expensive. So we did a couple calculations. We took 350 square feet of pre-treatment. One was a riprap area, one was a permeable paver area. We went to the permeable paver area 6 times in a year. And with union personnel and prevailing wages, it cost us around $1,800. That included 2 laborers. It takes them less than an hour to do that size paver, and no backhoe, no truck. And then we had a 350 square foot area of riprap. We went there 1 time a year. It was fully involved in sediment. The sediment had made its way past the riprap into the contaminant removal section. So that was now no longer functioning and a much more difficult thing to do. We had a backhoe, we had a dump truck, we had to remove all the riprap. We took out the sediment, we put it all back in. That cost us around $2,400. So 1 time, $2,400, 6 times, $1,800. So that's, and as Jamie mentioned before, every situation is different. So I'm not going to say to you that you're going to realize those same dollar amounts, but that's what we did in one area. And it's based on how much sediment goes there, what's contaminating it. So it's difficult. The bottom line is, if these things are functioning, we're getting clean water. The next part, as we move past the sediment removal, is the wear. So we want your water that is laden with sediment to come in and then stop. That motion allows the sediment to drop back in. Traditionally, you've seen pressure treated wares, you've seen granite wares, you've seen granite curbs, which we use all the time. But we kind of thought to ourselves, where our aesthetics are important to us here in this small 435 acre park. Well, what about boulders? What about just putting a line of mortared boulders in? So we've looked at a bunch of different types of materials we can use. On the left-hand side, it's the boulders. On the right-hand side, we used a gabion basket. So I know Groundwork RI uses a subsurface gabion basket. We use this gabion basket above the surface at the base of a permeable paver, as you can see it. But you can see what happened for a dramatic storm where we had some erosion. That gabion basket got the sediment built up, and now we had to have a difficult cleaning of that thing. So we're learning these lessons. We're hoping to pass these lessons on to everybody else. But you have a lot of options. These are wares here in Roger Williams Park. We incorporated art into some of them, so it's not just a granite curb. We also made a natural stream, or natural looking stream, with one of our wares. We used a pump out of a place called the Japanese Garden. We pumped the water up into a subsurface drainage system, and then we let it come down and make its way back to the pond through a granite ware and some boulder rocks. So it's very beautiful, high area for photography. Brides will go out there and see it. This is an early on picture. It's fully vegetated now. But don't be afraid to incorporate a bunch of other things into stormwater. I mean, art is a great thing to add to stormwater. Contaminant removal. So there's the argument about turf and sand filters versus plants. There's studies from UConn and a bunch of other places that will tell you that a sand filter will remove the same amount of contaminants that vegetated swales will. So I'm not a scientist, I'm a landscaper. So what I will tell you is the one on the right that we mow takes a lot less time to maintain than the one on the left that we go to our crews with, show them what invasives are, have them investigations, and what we've done, that's the least expensive is the sand filter on the right hand side. So maintenance challenges that we've faced. Did you lose me there for a minute? Maintenance.
Yeah, your audio is cutting out just a little bit.
Okay, you got me back again, Ryan?
Yep, we got you.
Okay, maintenance challenges. Funding is always a problem for municipalities. We face that too. So we had to build 42 stormwater sites in Roger Williams Park to address our MS4 permit. So how are we going to maintain those? We felt that training our staff was the most economical and the only way that we could do it successfully, and that's what we did. But it's a huge task. We understand that taking catch basins offline is expensive, but it's important. We need clean water. So you can either do it in staff, or you can outsource it. Outsource is a check that needs to be written. That's oftentimes more difficult than labor hours spent. So In addition to the challenges we have with maintenance, we wanted to pass this information on to the people that'll be doing this in the years to come. So we're heavy on education, reaching out to the schools and showing them how to maintain these systems. This is the one right out in front of our carousel, which maintenance has always been a challenge. So design with maintenance in mind. Use native plants. They'll flourish because they're growing where they're supposed to be growing. Use cost-effective designs. Repurpose. Use granite curbing instead of granite that you would buy for wares. We have a lot of discussion about whether we should put mulch on plants in stormwater areas. We don't mulch them anymore because, one, you have to replace the mulch all the time. They become floatables, so they clog up other areas of the system. So try and make these as maintenance free as you can. Create the four bays that are easily accessed and can be cleaned out easily. Design for the funding you have. So, you know, the size of these structures is directly related to the cost. So if you can't treat all the water, treat as much as you can. Whether it's geography that's a problem or cost that's a problem, do what you can to get the biggest benefit. And always design the structure for who'll be maintaining it. This is, again, one of our sites that we would redesign, but we leave it in place. So to the left-hand side of the picture here, this is a steeper than 3-to-1 slope. On the other side, and this is our river rock, our lovely river rock swale. On the other side is a lake, and that's where this water ends up. But we've made it impossible to maintain this area on the right-hand side because now our crews have to cross the river rock, and the equipment that they use, they can't cross. So this is one of our main training sites. It's just extremely difficult. So the sediment removal, one of the easiest things is a large basin. So if you can capture it in an inlet out in the street, that's one way to do it. Watch the slopes. You need to have access to all areas, both sides of these things, because you need to, that's how the workers are going to remove it. In water access, now we've locked ourselves away from where some of this material ends up in the ponds because it's not 100% removing all the sediment. We can't get to it. Know the capabilities of your equipment. There's specialized equipment to do this. It's expensive. So design for your staff and your machinery. Also the experience of your crews. We train all the time. We're always training our crews. And the experience of the crews and how they run their equipment is a direct result of the training that we've done. And most difficult for a lot of these, our crew members, is the plant ID. You know, they're not landscape architects, they're not horticulturalists, so it can be difficult if you didn't study that. So we use the best tools we can to make it easy for them. But we do have landscape architects on the payroll and a botanical center manager, and we ask them to do the training. And the crews have to be willing to adapt to this new thing. And luckily, we have a crew that's very willing to adapt. And again, it always comes back to the money. So these types of elements are more expensive than your standard catch basin. So a buy-in from the administration of your town or whoever it is leads to cleaner water. It's labor intensive, it takes more staff, you need a commitment. And the Clean Water Act is in place here in Rhode Island, and we need to start abiding by it. And that's what most of this work has been about. So how do we do it? We use pictures rather than words. So this is one of our sites. This is what our crew looks at. And if there's time at the end of this presentation, we'll talk about a system that we have called Green Cities and Survey 123 that allows our crews to do everything with an iPad. There is no more paperwork for us, and those reports get sent to myself and other directors. So this just identifies what area of what these different things are in these areas. And we did a search, like you had to find out where the wear was, you had to show us where the pre-treatment was, and it just tells you the basic maintenance that's required and the frequency of that maintenance. And they used to fill these out on paper, but now we all do this on the iPad. So we talked about plants. So when we set out with the Stormwater Center to train people on what they should take out, we use this list. What plants should not be in your Stormwater Center? Well, the palette of plants that shouldn't be there is huge. And these guys aren't going to learn everything they need to learn about that. So we moved away from what shouldn't be in, and we went to what could be in. What are beneficial native plants that you don't want to pull out because they're in there? That palette is huge too. So we reverted to what was planted there. We started with that, and now, because of our willingness of our crews, they've learned more about what can be in there. The mistake that we made in our first training, which we've rectified, is we went out in early April. These are the pictures we had. everything was in bloom. Nothing was in bloom early April. So our guys turned to us and said, hey, we're done. None of these plants are here. So we've learned a lot of lessons. For non-municipal private owners, if you're installing these things, do you have funding down the line to maintain them? You've got to have that in place before you build them, because otherwise they're not going to work. We've utilized volunteers here in the Parks Department to try and curb those costs. Are the property owners willing to do it themselves? Do they have to hire someone out? We need to gain support from the community and the public to make sure this is a problem that everyone wants to address. Here in the park, we have the golf course mentality for a lot of our attendees. If the grass isn't cut, they think we're not doing our job. They think it's unkempt. And Scott mentioned it too. You know, we have wildflowers that are adjacent to benches, and people call us and tell us, you got to cut that back because I'm sitting on the bench and this thing's hitting me in the back of the neck. They don't understand that it's wetlands. We even had a place in the city where a homeowner took it upon themselves to cut 10 feet around the bench so that they weren't going to be hit with wildflowers, and it was a stormwater area. So they damaged it. So provide maintenance that allows the green infrastructure to grow as a living system. You know, there's so many more things other than stormwater treatment. We have heat, so trees. We have perennial gardens and bees and all these things. These are ecosystems. They're small ecosystems, but they are ecosystems, and they're not just there to do stormwater. Make sure your designs are multifaceted. So if time allows, we'll talk a little bit about green cities and workforce, which is how we get our crews out into these stormwater things, maintaining them properly, and then documenting that maintenance to Rhode Island DEM. So I think that is it for me.
Okay. Thank you, Brian, for that great presentation. Let's do our second poll question, and then we've got lots of questions from the chat piling up. So we'll take 30 seconds here and try to get to as many as the questions as we can before moving on to the next presenter.
There was one thing I wanted to mention. There was a question about an alarm before. I'm not familiar with any alarm that tells you if your system's working or not, but I know Jim Murphy from Rhode Island College was working on an alarm for a catch basin that would tell you automatically when a catch basin was filled, and you would get an email or some other thing. I don't know how he made out with that, but there are people working on those types of things.
Okay. All right, so it does look like, yeah, not a lot of people are doing tracking. So yeah, hopefully we have time at the end, or even if you're able to stay a little later, Brian's gonna go over their tracking system. And so stick around at the end of the presentation. So I'm going to get to some questions here. One question is, at what point does it make sense to consider maintenance in-house versus contracting it out?
So I didn't feel I had a choice. You know, the other problem here in Rhode Island is there are no contractors that I'm aware of that are doing this specifically. You have that set of contractors that's willing to suck out catch basins, and they have that $200,000 piece of equipment. And then you have landscapers that may be more versed in pulling invasives and using that type of removal. But there's no contractors that are doing the both. And I think Rhode Island DOT and a lot of municipalities are struggling with a way to outsource that, because you don't have anybody right now that's doing that on a daily basis, particularly in like a highway scenario where a landscaping type company may not be used to working on a highway. They're not going to go out and do that type of work. So it's organizations like Groundwork RI and WRWC that are providing that work, and hopefully can expand their footprint and do a lot more than that out in the state. That's the situation here in Rhode Island.
Okay. I think we can do one more question and then we'll move on just because of time. It says, any specific recommendation for plants in bioretention systems over winter? Do you trim them? If so, anything to protect the bare system? And then it goes on to say, we have 2 rain gardens that look a little bare over the winter. And anybody can answer this. It doesn't have to be anybody in the panel if they have any information.
So we do cutbacks in the fall, and then, you know, that's typically, it's one, as far as vegetation is concerned, we do it once a year. Others may do it more frequently.
Okay, and then maybe do one more. It just says, have you considered using volunteers to help maintain vegetated areas in your BMPs?
We have, so we do a lot of work to Save the Bay and Wembley Ferguson, and they are often here in Roger Williams Park maintaining those plant type materials. The river rock that I showed you that an engineer designed, when we have a volunteer thing and the engineers are involved, we have them clean the river rock out so they can show the results of their design. So, but yeah, we have to. You know, we have 120 people that do a maintenance in 120 parks. So if you do the math, we just don't have the staff to do this. We always include our staff because of training and otherwise with our volunteer groups. But yes, we do that quite often here in Roger Williams Park.
Okay, I think we'll move on now to our next presenter, Jake Gorky with the Woonasquatucket River Watershed Council. He's going to be talking about seeded versus non-seeded systems.
Hi, everyone. My name is Jacob Gorky. I'm a ranger for the Woonasquatucket River Watershed Council. So that means I oversee and conduct maintenance on a lot of the stormwater systems that we have along our river and Greenway up here in Providence. There's several types of green infrastructure components that we deal with quite frequently. Those are bioretention basins, rain gardens, bioswales, tree filters, parking lots, and I also have on here green roofs, although it's not really a pre-treatment method. I threw that on there. So first I want to just go over why do we have plants in these systems in the first place. A hole in the ground is a perfect way to collect rainwater. However, with the addition of plants, we can actually go ahead and improve on those systems through nutrient uptake. We can improve the soil health, improve the stabilization of the soil within that system. There are systems that are just hardscape systems that do use river rock and riprap and things of that nature. But when we include plants in these systems, we're creating environments for pollinators, native birds, all sorts of wildlife can actually utilize these systems as well. So a good environmental resource. And then they are actually really good just for enhancing public green space. So I'll first start off with the bioretention and rain gardens. Bioretention basin is basically a system that is used to collect and allow for the infiltration of rainwater off of parking lots, roadways, and areas that see large amounts of sheet flow. They consist of a soil media that is roughly 1 to 3 feet deep, depending on the size of your system. They tend to be one of the more effective ways at removing contaminants as well, based on the amount of biomass that you can fit in there and the amount of soil media. So this bioretention basin here that you see is at Citizens Bank in Olneyville. We actually installed 2 of them, and they're kind of a great little example of how we may want to address seeded versus planted systems, what may be the better option for any given area. I'm sorry, here we go. First, I'm just gonna talk about the maintenance procedures and then we'll get into that. So we wanna make sure that every time we go by these sites that we're looking for trash or any sort of debris that may have accumulated within the system itself. We wanna make sure that the system bypass or the overflow pipe is open and water can actually flow out of the system if it does reach that maximum pooling height. Anything in there that might clog the system, again, we just want to make sure we get out of there. We want to monitor for any erosion issues that might occur within the system, so channeling, tunneling, and this especially goes for new systems, newly installed systems, because the plants have not necessarily had the adequate amount of time to establish yet or germinate. So those can be repaired simply by either adding river rock to the problem area, or if we want to add seeds to any of those erosion problem areas, we can go ahead and do that and then overlay it with an erosion mat or erosion fiber mat that will help further protect it. We want to keep an eye out for dead or dying plants. today's day and age, we see a lot of droughts, and we want to make sure that we're irrigating properly. So that could either mean going by with a water tank and watering each plant individually, or setting up irrigation piping throughout your system that will effectively get to each plant and make sure that it survives. The other reason why your plants might be dying could be that they're underwater for a period of time that is too long. If they're getting buried with sediment, that could be another issue. And in those instances, we've actually seen that here at Citizens Bank, we had to extract basically all of the plants that you currently see here within this bioswale and transplant them to the adjacent, or excuse me, bioretention basin, the adjacent bioretention basin across the way. And we have since actually seeded that area and actually improved the function of the system. The seeded areas have done a really good job at actually keeping the soil moist, which actually helps the infiltration of the water and also through the uptake of the plants themselves. So we've actually been able to pretty much fix the issue that we were seeing simply by moving from a planted system to a seeded system within that swale. And there was less open space as well for invasive species and things of that nature to actually infiltrate and cause more problems. If you do get sediment deposits around your plants, you're going to want to make sure that those are removed, because any sort of oxygen starvation to the roots can spell bad things for the plant and also degrades the soil health. We don't want to see eutrophic environments in these swales, so making sure that we have well oxygenated soil is really important. I'm going to move on here. Bioswales, these are typically low gradient conveyance systems, basically, that slow the flow of water from either a large open area, roadway, parking lot, and remove contaminants, basically by slowing the flow of water, allowing the vegetation that exists within them to pull contaminants and prevent trash and debris from actually getting further down the river or down the watershed. These can be mulched along the edges if you choose to do so. You can plant the edges as well to provide buffer, but in our experience, seeding the central area of that swale is actually a really good way to make sure that a lot of those nutrients are taken up and filtered out of the soil or out of the water. When you have open areas that are mulched, you have to be able to have a maintenance staff that can tackle invasive problems. Any open soil that we have or any open mulched areas that we have, we do tend to have problems with plants like mugwort, Japanese knotweed, among others, that we have to consistently be fighting with. Here's just a little sign that we like to put up, or we have a number of these signs of various configurations for each one of our stormwater management systems that kind of tells the public exactly what's going on. We have them written in English and Spanish. We try to make sure that everyone knows exactly what these systems are doing, so that they're not, so that they're actually cared for well by the public and people appreciate what we do. Again, this is bioswale maintenance, regular removal of trash or inorganic matter. That's something that you want to take care of. Basically make sure that your system is operating at maximum efficiency, prevent any blockage in the system. Same thing with weeding. Again, if you have to water your plants to make sure that they're doing okay during periods of drought, that's something to make sure you do as well. If you do have areas that build up with sediment or you have erosion problems, those are generally relatively easy fixes in a bioswale that has a low flow rate. We do a lot with just regular old garden tools, line trimmers, hand tools, and when we're doing our maintenance. So if the system does back up, again, you're going to excavate with just basically flat flat face shovels or line trimmers. Tree box filters, these are really cool. We have 4 of these that we just installed last year on Manton Avenue in Olneyville in Providence. They are a system that basically incorporates a tree that helps to absorb some of that storm water, as well as a soil media that's contained within a box that absorbs a lot of the storm water as well, removal of contaminants. One of the primary things that we did not foresee when these went in was the amount of sediment that was going to accumulate around the base of these trees. And as we know, that could effectively starve the root system of those trees of oxygen. So we actually have to go in about on a bi-monthly basis to make sure that these trees are getting the amount of oxygen that they need in order to survive and keep going. And that's about a 2-inch layer, every 2 months based on the area. And I'll move on here. Scuppers, I'm just going to echo a little bit about what Scott had said. If we drive by these things and we see a lot of sediment in there, it can be in the pain in the butt to remove all of that river rock out of there. It's not something that we have to do very often, but if we do see like any scouring around the edge of the scupper or any blowout, then that is something that we kind of have to address. Thankfully, we haven't really had to do that too many times so far. It can be backbreaking work. And again, here's scupper maintenance. You want to make sure that you're moving all of the foreign material and trash that gets in there that may cause drainage problems. Invasive weeds that may clog up the system. You want to make sure that those get out of there too. We don't want soil to build up because the main function of a scupper is to break up the water flow and to allow for a drainage course. Geogrid parking lots, these are a relatively new idea. This is one that's going up at, or actually just went up at Greystone Social Club near Cricket Field along the Woonasquatucket River in Johnston. These reduce stormwater runoff by actually allowing for a large scale area of permeable surface. They're more ideal for low use parking lots, like for events and things of that nature. But if you just have like a vacant parking lot that isn't being used for anything on a regular basis, this would be a great solution for that. Basically what it is a hard plastic grid that you put down and fill in with a soil media. You don't want it to extend above the edge of the plastic grid because as vehicle tires roll over it, you want that grass to be able to be protected. These should be accompanied by retention basins or swales as well, just to make sure that any sheet flow that does come off is collected. So you're going to have either 2 types of problems when you're dealing with standing water in your detention basins, bioswales. One of them could be an infiltration problem that has to do with your soil media. The first thing that I would check for is to make sure that you don't have excessive sediment buildup on top. If you go through the process of removing sediment from the top layer, whether it be 2 inches, a foot, you're never going to see that much, but and it's not draining properly, you can try seeding the system to see if you can get more water uptake that way. And in the event that it's still not working, before you go off and excavate the whole system, you should definitely check to make sure that you don't have a drainage problem, which you can easily find out simply by accessing. Typically with these, there's a perforated piping system that exists underneath with a cap on one end. So it's really easy to just unscrew the cap on these systems. I can actually see, you can't really see it in this picture here, but unscrewing the cap, looking down, making sure that sediment hasn't built up within your perforated piping underneath the system is a really good way. And if you do see that sediment starting to build up in there, then you would have to have a vac truck come and pull out all of the debris that is collected in there so that your system can drain more effectively. So yes, establishing whether or not you have a drainage problem or an infiltration problem is important. During the install, this is Farm Fresh, Rhode Island, of one of our biodetention basins. We noticed that a lot of scouring had taken place around the parking lot outlets, which are positioned in the fore and aft portions of this detention pond or detention basin right here. We kind of had to go ahead and change the plan on this. So one of the lessons that we learned was to be flexible. The install of riprap basically allowed us to prevent further erosion problems and sediment deposit problems that were occurring in this basin. And then we went ahead and we more heavily seeded the forward portion of this adjacent to the parking lot to prevent further erosion and the sheet flow coming off the parking lot. Benefits of seeding, you're going to have a much better vegetation establishment initially with seeds than you are with a planted soil. That's beneficial for a couple of reasons, because you're going to have a lot less open soil space. These biodetention basins that we've seen aren't really wet all the time. A lot of the time that we're looking at them, maybe between July, August, September, October, there's a lot of very, very dry soil in those months. So what that means is if we do have a more intense storm, erosion can become a big problem. So when we seed in the springtime and we get really, really fast germination of these seeds and everything blows up really fast due to springtime runoff and rains, it actually goes ahead and it reinforces that soil much, much better. And again, when we have much tighter planted or seeded areas, they're a lot more resistant to invasive species. We have not really seen any invasive infiltration within these systems in Olneyville as of yet. When we go around to maintain them, the only thing that we're really maintaining is the perimeter of these seeded systems. So in terms of the efficiency of maintenance, it's just a lot more efficient. We're not running around to every single plant that we have planted, collecting trash out of them either. Again, it's really just a perimeter thing. Go around to a few trash pickers, pick up the trash, line trim around the edges if you have to clean up the edge. And that's much, much more efficient than trying to maintain a bioswale or a biodetention basin that has planted plants in conjunction with a bunch of invasive species that are now living with it because you had a bunch of open soil that was easy for them to germinate and infiltrate. So we do like the seeded system a lot. And I think that as we move forward, well, as an organization and societally, we're going to be seeing a lot more stormwater infrastructure being built. And I think the ease of maintenance is something we definitely should be considering. And again, they're self-replenishing systems with the seeded systems. So you don't need to go ahead and plant new plants every single year. There are uses, however, for actually going in and planting native shrubbery and things of similar vein. They can provide barriers for site barriers if you're looking to do that in your area. They're much better at bank stabilization than just planting grass. So if you need that within your system and you can establish those plants, that's a good thing to try and do. And then if you're willing to maintain the system, they can have a much nicer appearance. However, there's a lot more work than maintaining a seeded system. Requirements for planting, definitely want to plant them high, 1 to 2 inches above the root flare, or is probably a good, below the roof layer is probably a good starting point. We do see sediment accumulating around these areas in a lot of our bioswales and detention basins. So if we plant them high, we can actually kind of prophylactically attack that problem. Tighter spacing will limit weed pressures. We've talked about that. And one of the important things I should mention too is to actually plant a buffer. If you're not dealing with like an inlet structure, planting a buffer between your swale or detention basin will greatly enhance the ability for it to withstand erosion issues. So again, lessons we've learned, it's really important to observe before we plant to make sure that our system is functioning properly. And then we can determine exactly what plants we want to put in, or if we want to seed, how we tackle the issue. We're not always dealing with something that falls within the riparian zone in terms of the environment. Let's see here. I lost my PowerPoint. Here we go. Sorry about that. All right, I'm not sure.
99% of the way through, and you almost have.
Not sure what's going on here. I guess I'll just kind of wrap it up with that. I listed our contact information in case anyone wants to ask any questions or type up any questions and send them in. Yeah, I think I'll end with that.
Okay, well, thank you, Jake. I appreciate that.
Yeah.
And I think we're going to hold off on questions right now, and we're going to move right into Steve Ricci's presentation. And Steve is with Groundwork Rhode Island, and he's going to be going into more detail about permeable pavers. Take it away, Steve.
All right, thank you, Ryan. My name is Steve Ricci. I'm from Groundwork Rhode Island, and we install permeable pavement as well as maintain it. We actually do it for all BMPs and green infrastructure. As Brian said earlier, we actually do a lot of these types of maintenances that we've all been discussing all day. But we are one of the companies that is not able to get that $200,000 truck and kind of move on to that next level. So definitely a lot of struggles in that aspect. But I'm going to talk about permeable pavement today and the lack of maintenance and some of the issues that we've actually seen out in the field while maintaining them. So just really quick, how does permeable pavement work? There's a construction detail of it right there. The top layer is concrete pavers that are basically look like your standard pavers. All permeable pavement is not all pavers. I'll show you further into the slides that there are 4 to 5 different types of pavements, but the more common one that we're seeing now is the permeable pavers. They're actually a 1/2 inch thicker. So they have a 1/2 inch more height to create more depth and space in between each joint. But underneath the concrete pavers, you're going to have a joint material, which is usually rice stone, an open graded bedding course, which can be anything from a stone dust to a rice stone, depending on what type of subsurface you're dealing with. Underneath that, you're going to have another graded area that's packed enough to actually hold and withstand traffic, so you don't get any dips and bubbles, and we get the frost heave issue out of the way, so the pavement actually stays level. And then underneath that is where you're going to have your reservoir. Some, as you can see in this picture that we have here, have an under drain. The under drain can go to another further reservoir, or that can actually go into a drainage basin system, or wherever you're actually going to flow the water that you're taking in. But not all of them have that. Some will actually just have a reservoir that just permeates into the groundwater. After each rainstorm, it just replenishes itself and then permeates into the ground itself. So not all of them have the actual under drain that pipe the water into different areas. It all depends on the size of the unit you're doing, if it's a parking lot, if it's a street, if it's just a sidewalk, or if it's even just an inlet to a rain garden. So what happens when permeable pavement is not maintained? This is just a brief shot actually that was sent to me by Unilock, who is a manufacturer of the permeable pavers. And it shows here on the top area that these were, I believe the study or the area that was put in the spring of 2018. So here we are in September, and as you can see, these areas here, the darker you get into the more of the reds or oranges, they start clogging up. So this is something that wasn't maintained, flow rates falling down. So you can see the top area gets a lot of sediment in it earlier. So these areas are actually catching sediment before falling down into the further areas here. And then by October 2019, so you're talking about a year and a half, this system was no longer working as permeable pavement, but rather just a paved area. So this area that was not maintained, it just ended up not working. Without maintenance, it's the same thing as actually just paving the area. Some of our maintenance methods includes vacuum sweeping, power washing, power and blowing, annual inspections, litter removal, and winter maintenance. I'm going to get into all of those. So for vacuum sweeping, the equipment can be very expensive. The trucks can be between $100,000 and $200,000. Some of the hand units can be, $8,000, $9,000, $10,000. And these are for larger areas. If you're doing something small, like some of the examples Brian showed in the park, you're looking at a $300 attachment that goes onto a weed whacker, 2 guys, they brush out the rice stone, pop it back in. You don't need these expensive hand equipments that are into a suction truck. But when you're dealing with sidewalks and pavement strips and parking lots, you're going to need something larger. In order to get that top layer out, and you're going to need something more powerful too for some of the things that are jammed in, as Scott mentioned earlier, which I'll get to, in cigarette butts being a very large issue right now, and it's being battled in a few different ways. But most pavement right now requires to be completed between 3 and 4 times per year, but this is all depending on the scenario you're in. If you're seeing a lot of traffic, it could be more. If you have a really bad winter, or some municipalities, depending on what they use in the winter, will actually be out there every 2 weeks or even after a storm. We'll get into winter and how we're dealing with that. But so the 3 to 4 times per year, that's kind of a seasonal thing. That's kind of where the manufacturer will tell you should be, but other places do it more. Here you see an example of the large vacuum sweeping trucks versus some of the small sweeping equipment. Obviously, the small areas, they're a lot less expensive. They're a lot easier to maintain. And some of these hand machines here, it's a quick thing. When you have this push behind vac, it's one guy, he goes out, he vacuums any of the debris, small sediment, fine dusts, cigarette butts, that stuff. Hopefully, if it's powerful enough to suck out the cigarette butts, they'll get wrapped up into the machine, they'll get sucked up, they'll be gone. You're talking about one guy, 1 hour. If the BMPs are linked close together, say a park or something, you're talking about multiple in an hour. So obviously the smaller ones are a lot easier to maintain. Power washing. Some of these areas require power washing. And the way these power washing units are set up is they're enough to basically power wash the sediment out, and then usually get sucked up after, or it's pushed into one general area where then it'll get sucked up or power washed right off the permeable pavement. The power washing, the way it's set up is it's usually made to blow out 1/3 of the media or rice stone that is in the joints. All these things, whether it's a vacuum, power washing, blowers, they're usually made to take out 33%, which is that top layer, which usually holds the sediment. It's usually made to blow it all out or brush it out or power wash it out so that you can get the system working again and taking on the water. And usually after this, a couple bags or, a simple quick yard of rice stone will be used to actually go right back into the joints. So that's also part of the maintenance as well. Any of these things you're seeing where we're power washing or we're vacuuming or we're doing heavy sweeping, we have to replenish what we're taking out, because sediment's not just going to come out on its own without actually taking out the media in between the joints. Here's some power blowing equipment. Sometimes it's as simple as blowing down some of these areas, keeping leaves and debris off. If during the fall, I've seen some contractors and maintenance guys only do one fall cleanup at the end of the year. But what happens is if you get some of the early leaves that fall in October, they'll settle on the pavement. Well, some of the leaves, especially not oak leaves, things from honey locusts and the littler leaves, they'll actually just start decomposing right there. And that the decomposition turns into a mud, it turns into a silt, it turns into a clog to the system. So instead of getting into an expensive issue of, now you have silt, mud, debris inside all your joints, once a week, they send a guy out with a blower, he blows the leaves off, and you just completely, mitigated having a more of a disaster on your hand. And so sometimes sending out a guy to blow out a parking lot once a week for 6 weeks in the fall is going to be a lot, it's going to save you tons of money rather than sending out 4 guys with vacuum trucks and redoing rice stone and getting all into that. It just completely changes the outlook of how much you're going to spend maintenance wise. We talk about preventative maintenance. Well, there can be preventative maintenance, prevent more difficult maintenance by doing smaller maintenance. And these small maintenance are usually, like I said, one guy, smaller equipment. They're quicker to do, they're easier to do, and they can be less impactful on your budget. As you can see, the power blowing equipment, it comes in multiple different sizes, from a standalone ride-on guide to a bigger system where you can actually put it on tractors. This all depends on the size of the unit you're doing. If you're doing something small in a park or little sidewalks, you can even get by with a backpack blower that has around 300 CFM and just use some of that, which is the equipment that we all have that we can use just in parks and recreation maintenance. So the types of permeable pavement, you're going to see interlocking pavers, concrete, which is porous, same thing with asphalt, which is porous, plastic grids, and the plastic grid paver locks. The permeable interlocking pavers, they should be vacuum swept at least twice a year, like I had said, usually 3 to 4 times a year, but some will do more. Leaf and organic litter should be removed before decomposition occurs. Power blowing should be completed on an as-needed basis. Some people blow these things down weekly as just, they put it into weekly maintenance, whereas a more larger maintenance 2-3 times a year is vacuuming it. In between, we hit it with a blower. And when we do these in-between maintenances, again, they take off some of the stress of doing these big maintenances that are needed. And in between storms, we could get a thunderstorm, brings down a lot of debris, we have trash, we have litter, that stuff being cleaned up once a week, it saves you from clogging the system. Rice stone in the joint should also be replenished. This says on a year-end basis, and this is what's listed by Unilock and Pavestone, but it's usually done when you actually do some of the bigger maintenances and you actually blow out. We like to keep it replenished. Some of the common maintenance issues you see with permeable pavers, winter snow removal is a big issue. Using fine sands and chemicals, you have to remember that fine sands are going to sit in a sediment, and any chemicals you use are going to go into the groundwater. So that's something to think about when we're doing winter maintenance. There are some places out there that will actually just plow some of these areas in small parking lots, but they don't want to use salt because you obviously don't want to get the salt into the reservoir depending on where it's going. But what happens in those issues is they let it kind of ice over. When the ice fills in the cracks in the joints, now you just have pavement. You don't have permeable pavement anymore. So, and the larger sands, the larger, more gritty sands that you put down, they're too large to fall into the cracks or into the system to clog. The problem is you can order that stuff as much as you want, but the large stuff breaks down to the fine stuff. So you're never really going to get what you want to actually put down. So winter is very tough on permeable pavements, especially in New England. We have a lot of lack of vacuum sweeping. Some of these units are put in. We've done jobs where we've actually put in aprons for people, and they've gotten filled with sediment, filled with debris, and they no longer do what they're supposed to do. They don't take on stormwater anymore. There's a lack of sweeping. Some cities will be asked, or they'll get a grant, or someone will get a grant and they'll put a system in or a sidewalk in, and the city doesn't have any of this equipment to actually take care of it, and they don't plan on getting any of the equipment. This was kind of something that was thrown at them, and so now they're in a system where, hey, we're not going to vacuum sweep it, we'll just blow it as best we can, and what happens with it happens with it. And this is what happens. The joints get clogged. things happen over time. Leaf debris will get into the units, and you'll end up in a rough situation. Here's just some examples of the permeable pavers clogging in the joints. As Scott said, there's a cigarette butt problem. They've been finding beer caps. When you squash them in half, they fit perfectly into it. So we've seen a lot of sediment and issues and cigarette butts clogging the system. Well, this is a way they're actually combating it with now. Right now they're doing studies on whether or not is this a solving issue where you do different types or different patterns in different bricks that actually have larger holes. So if something does get in there, it's not completely clogging that area completely. So it's allowing more water to get in, and maybe these larger squares takes longer for the debris to get in there and clog it, and it's easier to vacuum stuff out of a bigger area rather than things getting compacted and stuff into these joints. So we're starting to evolve now, almost how do we make it less maintenance, make it easier? Well, here's a perfect example of what they're doing. Here's another example of this same thing here. It's the joints are actually cemented in, and these pavers are actually in the shape of a big L, and they form these squares that are easier to maintain. So the concrete and asphalt issues, they kind of have the same thing. Vacuum sweeping should be at least done. Sometimes these are more often. They have smaller holes. They're very porous, 3 to 4 times a year. Again, a lot of people do it maybe after every snowstorm, after every big storm we have. Leaf litter should be removed the same way. The power blowing should be completed on an as-needed basis. And these actually, when they're damaged, need to be resurfaced. So that can happen from plowing or vehicular damage and large equipment damage. Some of the common issues that we see, again, it's that winter snow. There's a big parking lot down at URI, and underneath is a giant reservoir. Well, they can't use salt there because the salt will completely turn the reservoir into salt water, which is then pumped into other things. So they don't put any salt on it. They don't put any signs. What do? They put up signage. Be careful. This is going to be an untreated area during snow, untreated area. You see it a lot, any of the times you see a lot of these parking lots now, you'll actually see signage just warning people that, we may not be using salt, we may not be using heavy sands, we're just plowing, be careful. And the same things happen with these, the lack of vacuum sweeping. With something like this, it needs a very powerful vacuum sneak. It needs one of those big trucks to really suck the stuff, suck the sediment, suck the debris out of the small. You're dealing with very fine debris that's actually clogging the porous concrete and asphalt. And so as you can see, a couple of examples there. The example on the right is actually from the UNH website, where they have a leaf actually frozen in the ground, and that area is currently not doing anything. That's not permanent. Obviously, when it defreezes, the leaf gets sucked up, but during that winter month, that area may not be working as well. And on the left side, you can see the right side of the left photo has no sediment, and the left side is actually complete sediment from a construction job that was taking place next to the area. So maybe that's something to be mindful about during the construction season, or if there's a nearby job going on, these things should be swept at the end of each day rather than just the 3 to 4 times a day. And these are the grid permeable paving that we've been seeing. And sometimes these have grass, sometimes they don't. This is something newer that you really say they're plow safe. You can see the white markers. You can actually make parking lots out of it. These are nice because you can do low power blowdowns, low power washing, and just resurfacing the media. These clog less. They have less issues. The plastic grid's holding up. You can see how much space and how much water they can actually take in without clogging. You could dump a truckload of cigarette butts on this, and it's not going anywhere where they can easily be blown out rather than even be swept. A blower will simply blow everything out because the joints are just they're so large. With some of these issues, some of the common things we see is the vacuum sweeping in the system. Some places, we've heard stories, we've never seen it, but they'll actually go in there with a big vacuum sweeping truck and just suck up the debris in something like this. Whereas something like this, you don't want to use big systems. Using too much force while blowing down the system, using too much PSI while power washing. Basically, if you go too powerful at these systems, they're the opposite of the other three. You'll actually blow the media around. You'll actually do damage to the system. So a system like this, and again, if there's no training on this, no one will know. So it'll turn into a giant issue. I think I lost my system there, but I was actually at the last slide there. So that system could actually end up getting hurt by actually putting too much power into it, actually bring in too much power and equipment. So depending on what system or what permeable pavement you have, they all require different tools and different systems. And it's the best thing when it comes time to be in maintenance is being trained. How do we do it? How do we do it properly? That'll keep the system running for the longest period of time.
Okay, thanks, Steve. Appreciate it. I know Steve's been battling an illness all week, so thanks a lot for pushing through that. Great job.
Absolutely.
Yeah. All right, now we'll move on to Eric Beck with the Rhode Island Department of Environmental Management. He'll be our last presenter, and then hopefully we have some time for questions. Take it away, Eric.
Okay, great. Can you see my screen?
Yep, we can.
Excellent, excellent. I just wanted to introduce myself. You can see my bio and on the website for the Providence Stormwater Innovation Center, but also these will be recorded, these presentations. So, you know, to be respectful of your time and to try to get you out of here and on to maybe save some time for Brian to come back and talk to us about how he uses tools to track the maintenance. I'll probably go fast on some of these slides, but my name is Eric Beck, and I'm an administrator in the DEM's Office of Water Resources. I manage the groundwater and freshwater wetlands permitting programs. In the Office of Water Resources, we have a group of scientists and engineers that monitor the state's waters on a regular basis. We assess them based on the water quality criteria that we have here in Rhode Island and make a determination if they're meeting the criteria and or whether they're impaired. We have my group pretty much does all the land development permitting. So any large project that you may see in your municipality, anything greater than an acre of disturbance comes to the state for permitting of the design. And so that's my background. I started with the department 30 years ago, approximately. I've been in the stormwater field. I started out as a wastewater engineer with a construction background. But in 2000, I started working in the RIPDES program. I'm focusing on point source discharges to our waters of the state. And along came stormwater, municipal stormwater back in 2003. So I started becoming familiar with the struggles of the municipalities in maintaining their systems at that point and where they were starting from. And if you go back 20 years and you look retrospectively how far we've come in terms of how we look at the water quality and the recharge aspects of stormwater management, it's amazing. So I'm very honored to be invited to work with this panel after seeing 20 years later and seeing people implementing green infrastructure, seeing the people who actually care for and maintain these BMPs now give us feedback on, hey, this is the way we should do it. It's now come full circle, and it's very exciting for me. And you know, this is just a rock star panel of people that have come together before you today. Ryan has done a great job pulling this together. Jamie gave you a really good feel for how these things function and how maintenance is tied to performance. Scott, you know, raised a lot of good issues in terms of being, you know, involved at your level, at every level in the design, installation, and maintenance aspects of it to get it right. It's a full circle. Brian echoed a lot of those same things and gave us some really good insight on, you know, what's easy to maintain and what's not easy to maintain. And I think between Brian, Jake, and Steve, you get a really good sense that these BMPs it's all about where they're being placed and what their function is. Some BMPs are more commercial or institutional. Like I worked a lot with the Providence College in St. George's in Newport, where their bioretention areas and their permeable pavements were absolutely gorgeous. But that's what they do. And that's what they wanted. They wanted a showcase. They wanted something pretty. I've worked with the town of Bristol. You can see on my screen here, this is one of my favorite sites. This is basically a retrofitted parking lot and a very simple design of bioswales where they actually, by reconfiguring the parking lot and providing this treatment, were able to get more parking spots than they had before. And when we first started the project, their consultant was telling them there was absolutely no way they could ever do this. And then they kept pushing forward. They had a very good advocacy at the local level. And so anyway, there's an appropriate BMP for every spot, but you have to think about it and you have to be involved in that discussion. So those are great themes. I just wanted to say that, you know, why we're here and how you're part of helping us protect, preserve, and restore our waters in Rhode Island. Stormwater is definitely the most significant source of pollution that we have here in Rhode Island. You see the map on the right is a map of all the impaired waters in Rhode Island, the pink, the purple. The blues that you can see are the unimpaired, and you can see there's quite a few. This is older data and it's updated all the time in cycles. You can see information on our website relative to the newest assessments that we've done. But it really reflects the fact that we have impairments, or we have polluted water bodies that aren't meeting their criteria. We assess them on a regular basis. And the data early on showed that we could draw a direct correlation to stormwater events, especially when you look into smaller watersheds. And one of the best example is, you know, bacteria and beach closure events. DEM has made a significant investment in green infrastructure, promoting it. I'll show you some of those examples later on. We've been working closely with the Rhode Island Infrastructure Bank and other grant and bond funds. So when you see the opportunity to vote for a green bond fund that includes stormwater improvements, tell all your friends and family to go out and vote yes. And I think there will be another big one coming soon. There's been a lot of strategic investments by municipalities. You look, some of the examples here, Roger Williams Park, down in Newport, I could say South Kingstown, Middletown, East Greenwich, Woonsocket. I mean, it's across the board. Here in Bristol, this is one of the first underground gravel wetlands that I've ever seen. I've only seen two built that I've been involved with, and this was the best one I've seen. And look how beautiful it is. There is some maintenance, but again, it fits. It's a park. They have maintenance people, and they wanted an aesthetic. So I wanted to just give you a quick tour of some of the rules and regulations so you know where to find them. I'm not going to go through them. Just going to quickly clip through these screens. You can find our rules for stormwater management design and installation on the Secretary of State's website. And I'll show you some links, but just to know that there are some rules about how systems are supposed to be designed. That includes a standard for maintenance and operation and having a plan for each BMP, as we talked about. Those maintenance plans have to have certain elements to it. Most importantly, a diagram of the BMPs and some assurance that they'll be maintained. And I also wanted to make a point just to let you know that Rhode Island does now have a permit search or permits are now posted online, so the approved plans can be found online, and I'll show you where that is on our website later. But back in 2010, we developed a new stormwater design manual that emphasized the focus on water quality and recharge in addition to the type of stormwater management we did in the past, which was maybe at best managing conveyances and large storms with detention ponds. But this was a significant step forward for the state of Rhode Island. It was amended in 2015 for some small amendments, but now being 20 years old is ready, or 10 years old is ready for a revision that addresses some of the things that we're talking about today. You can find that. Visit our website. It's very simple, dm.ri.gov/stormwater construction. That's one way to find it, and it should be an easy way to remember. You click on that and you can find our resources page. So I just wanted to show you that that exists, and let you know that that guidance manual that I'm going to be talking about is also on that page. If you look on your right hand side, you can see we have additional resources links, and then we have resources for designers. That's something that you should be able to find. And in that manual, in that guidance manual, we have design guidance for each of our structural BMPs in Chapter 5. In that, that also includes functions for operation and maintenance, so considerations for that in the design. Now, granted, this was in 2010, and it's hard to capture every aspect of that, but I think the manual did a good job of acknowledging, this is another picture of the manual on bioretention. It shows you the basic elements. They're not always sized like that. They don't always look like that. They don't have to have all the elements, but this is a basic design. And as you can see, some of the things that we saw today don't look anything like this picture here. And obviously, there's a difference between looking at a set of plans that are 2D and a picture that's 3D. But a lot of these practices are very similar and have the same functioning. And each one of our criteria also has maintenance requirements. This is just a summary on the right side here. But if you look a little bit deeper in Appendix E, we have guidance for developing those O&M manuals. And we have checklists, like Brian has and showed you a brief glimpse of, and you'll see maybe later. Those are templates. They're meant to be adapted for the BMP. And as long as the main elements of that, basically that you're doing a routine inspection, and that there's some routine maintenance, and that there's corrective action that happens after you do that inspection. And I think we all acknowledge that, as we look at designs here at the state level, and we require O&M manuals to be done, just like anything else, it's essentially a draft when we see it at the design stage and when we approve it. Once the system is built, then I think that's when the O&M plan becomes real and can be amended or modified to fit the BMP and how it was installed. But that's the point at which, we'd really like to see that collaboration happen at the local level where, like Scott said, if somebody was able to, talk to the designer during the design stage and while the city was reviewing it, or when the state was reviewing it, asking if the city was okay with the design, if somebody was able to point out to the designer that a tree overhung this area or that the system was in the wrong place, those would have been valuable comments and saved the city a lot of time, money, and heartache. So that's where you really have to emphasize that, is there an opportunity to talk to the people in your municipality who do the reviews and approval of these technologies to get you into the discussion? Because we all have a role, and I think that's really important for us to realize. We have our designers, our owners, our maintenance people, our contractors, our permit reviewers, our municipal officials. And I'm really interested in my part, essentially, is trying to connect the lessons learned, the things that we're seeing from the contractors, from the maintenance crews, and feed it back to the design community and the municipal officials and the permit reviewers, and improving the outcomes. So that's why I'm so excited about hearing some of the things today, and that so many people signed up for this training, because there's a huge interest out there, and we need your feedback. So as Brian mentioned, back in 2003, we came out with a new rule in Rhode Island that was in accordance with the Clean Water Act. EPA required the state to basically issue a set of rules to address municipal stormwater systems. Part of that requires that the MS4 submit annual reports to us and develop inspection schedules for long-term O&M. And that's why you're seeing, as these programs mature, the city of Newport and Brian at the Roger Williams Park have developed these programs, and also this ability to provide employee training programs. This is the culmination where the Providence Innovation Center is a great opportunity, a great platform to share this information and to provide training for your staff, yourself, professional development, and it's been a great opportunity. The title of my presentation was Moving Forward, so I did want to give you that background, because I wanted you to know how important it is, what you do and what role that you play as that field staff component, as that person responsible for maintaining the end product, how important it is and what role you play in restoring our waters. And I can point to numerous examples where we do have results, and we do have really great success stories where water quality improvements have been realized through the implementation of these green infrastructure, and it's truly exciting to see. I wanted to give you those kudos and basically say that we're working hard moving forward on particularly addressing some of these design issues that the people who maintain these BMPs are seeing and recommending, and how do we get that back into the loop? Well, the Woonasquatucket River Council and their river rangers are maintaining BMPs for the Rhode Island Department of Transportation, and it's largely due to a consent decree that we negotiated between EPA, DEM, and the DOT to go out and do some of these restoration activities and to incorporate these BMPs into their projects going forward. So this is at the same time, we were working with their design community to identify the types of BMPs that might fit into a roadway system, and how do we get green infrastructure into that. And they, it's not necessarily all green infrastructure, but it was a great manual, and it does have some really good BMPs, and they did put a lot of thought into maintenance for those types of BMPs, because they didn't want to have a high burden of maintenance on those things. So that was phase one of that manual was completed in 2019, maybe early 20, probably late 2019. We're now working on a second phase two of that to complete it, and it will include making these BMP designs available in AutoCAD files that can be where we'll have another opportunity to work with our design community to see if we can get some of these things right and some of these lessons learned. So that was one effort that we've recently completed and is still going on. And the other was, I wanted to give a lot of credit to the SNEP network. They're the ones that are sponsoring this and hosting us here on this training, working with the Providence Innovation Stormwater Center. But we're also working with Jamie Houle and a larger group of people representing the region, Mass DEP, and others on a regional stormwater retrofit manual. We were able to, it's a 2-year project. We're able to get some funding from the network and some professional expertise. Jamie is leading that effort with a great group of people researching it from both Massachusetts and Rhode Island. And the hope is that it actually will fit. So if you look at the big picture, our manual really fits well for certain things. It fits our current design manual at the state level, but it's mostly subdivisions and larger developments, commercial developments, industrial developments. And then you have a manual for roads. And now we'll have a manual for smaller projects and retrofits and things that can fit into the landscape, like very much similar to what all these speakers showed you today. Here's how we did it. Here's how we used these natural areas. Here's how we created a curb cut and disconnected our impervious areas or our pavement from the water body, so there wasn't a direct connection. And that's really the true source of most of the pollution, is that there's no filtration, there's no treatment between what generates the pollution in the stormwater and the water body. And that's what we're trying to do. We're trying to disconnect it. And by the way, if we can infiltrate it, great. If we can put it through a filter, great. And those things will pay huge dividends. So I wanted to let you know that that work is going on. We're probably 6 months in to the project, and what these types of trainings, this type of feedback, this type of information will definitely be incorporated into the recommendations and design of that manual. And I think that will be very, very big for everyone. So I'm really excited about working on that. We're also would love to take an opportunity to update our manual now that we've worked on a manual with DOT. We worked on this retrofit manual and start feeding back some very important updates that we've learned are necessary over the last 10 years of using this manual. I'll give you one teaser. We've been working and glad to hear that Jamie and UNH just released a new specification for bioretention soils that will allow us to update our manual and facilitate, get better designs so that, you know, you may not see it necessarily from the surface of the ground, but what you won't see is failures. And I think that that's how the end result will be: better designs, improvements that we can make along the way. It's due for an update, and if budget and time allows, we'd like to start working on that as we learn in these other processes. I also want to let you know that the Office of Water Resources is in the process of drafting a new MS4 permit. The last one was issued in quite a long time ago. But since then, the EPA Region 1 has reissued the MS4 general permits for Massachusetts and Rhode Island. And Rhode Island is going to be starting the public workshops on that beginning in this summer. So I encourage you to participate in what you've heard today and feed that information back to the people that you work with and participate in those workshops. The other thing that I wanted to, and is very much tied to the reissuance of the MS4 general permit, and definitely is a good nexus to what Brian wanted to talk about on tracking and how do we record this information. The permit requires annual reporting. The municipalities have to report on how they're doing, but now it becomes more important because basically we're looking at restoration plans and we're saying how long, what needs to be done in a particular watershed. They're called stormwater control plans. and they're meant to identify what the impairment is, what's contributing to the pollution, and what has to be done to get it back to standards. And you know, the municipalities and the people on this panel are probably very familiar with that. But in a larger sense now, we're going to ask the communities to map, track, and account for the BMPs that they have installed over the last 15 years, and understand what the benefit of that, what the performance of those BMPs are. And maintenance has a direct impact on performance, especially from a water quality standpoint, certainly from a hydraulic standpoint. So understanding that EPA has developed a tool that will help municipalities do that. I'm currently working with EPA Region 1 scientists on a project that will basically improve the pollutant removal curves for these BMPs and apply it to a system up in Mystic, Massachusetts. That watershed, they're going to be working with the municipalities in that watershed to introduce this accounting and tracking tool and how they might be able to show their progress towards meeting the pollutant reductions that are required. And we're going to be allowed to sit in on that and see how that goes. And in addition to that, you might have seen, if you're a municipality, you might have seen that through the SNEP network as well, Rhode Island and Mass have issued a solicitation in this area, in the state of Rhode Island and Mass, to do a bi-state pilot project with municipalities in Massachusetts and Rhode Island, where they might have a common watershed or a common goal, and do the same thing, introduce them to, you know, what is it going to take to develop this kind of accounting and tracking at the local level. And we're right in the process now of evaluating the applications of people who volunteered, but we got a really good turnout in Rhode Island. We limited it to a few watersheds, but we got 6 or 7. We've got a majority of the municipalities that were in those watersheds volunteered, and now we have the hard choice trying to select the one that we can work with. But you know, all of this.
Hey, Eric, I hate to jump in here, but we're almost 15 minutes gone over with time, so I wanted to kind of wrap it up here. I know there are people that are going to try to stay on here for the bonus presentation by Brian, but I wanted to thank all the panelists for putting in all the time and the effort with their presentation, and thank everybody that attended the webinar. And we will stick around and keep going here if people have time, but I just wanted to address that and make sure that everybody knew that it's okay, and we will get to these. We do have a few more questions and stuff and that bonus presentation. So were you, Eric, were you close to wrapping it up, or?
That's my last slide.
Okay, I apologize for interrupting, but yeah, I just wanted to address that.
Great.
Okay. So I will go ahead and ask a couple of these questions, if that's all right. And so these are kind of all a compilation of throughout the presentation, so they're not really intended for one particular person. So feel free to jump in. It says, can you tell us about the cost per acre treatment or impervious reduction? Not sure who that's to, but anyone? That makes sense to anyone?
Sure. And Jamie can probably speak to this too, but in developing the tools that I mentioned that EPA was developing, they do have some cost information on their website, and they do actually have developed some tools that communities can use to you know, evaluate the cost of different BMPs and how they've applied them within a watershed. I think that's one aspect of it. Is part of developing these performance curves. EPA has also develop some cost information that basically is, I think it's based on hours. Is that correct, Jamie?
Yeah, based on
Yeah.
hour for operation and maintenance.
So it's kind of normalized, and I think that was a good way to do it. So we can definitely, Ryan, work with you to, if that's important information for people, we could definitely provide links in the future to that. But if you visit EPA's website and you Google the Opti tool, or you Google the BAT, that BATT, if you Google those two words, you'll come to that website and you can see that information on their site.
Okay. And this is a question about seeding. What type of seed mixes do people use?
We use a conservation seed mix from Lesco, and we combine that with a New England wildflower mix that seems to do really well. Tall Fescue and Rebecca are two of the plants that seem to do really well in our detention basins.
Okay. We did have one more of a comment about power washing and that it should be done at a low angle. Maybe it was based on that one graphic that you had. It looked like that guy was kind of pointing it straight down, but that it would actually drive the fines into the permeable pavement system below. So just maybe more of a clarification, but
Yep.
Yeah. Okay. Yeah, I think that's kind of all the questions we had. So Brian, is Brian still here?
Yep.
Do you want to take it away and do your presentation on tracking? For those, there's still 90 people here, so people are interested.
All right, do we see my stormwater screen?
You see the temple to music.
Oh, you do? Oh, enjoy that for a second. How about now?
There we go.
Yeah. So some of the, I want to preface this with some of the elements of this don't work on a laptop because this is iPad driven. So you're going to see the bulk of it, but not necessarily what can be done. So I have no endorsement for, nor do I get any royalties for Green Cities or Survey 123. Survey 123 is widely used by maintenance personnel for lots of things. Here in our department, we use it from everything from broken benches in parks to stormwater to cutting. And it just allows any member of the department with an iPad in a park to identify liability, a broken bench, a stormwater site, and input some information and create a work order. So we went a little further with our stormwater sites, giving our employees tools to use to know exactly what they're supposed to be doing because it is a complicated measure. So basically, this is a form that they would fill out. They would say who it is. It would say the time and date automatically. It would ask you for a completion date. I'll say it's for 1 week. And then it'll ask you for a site ID. So we have all of our stormwater systems in the park listed, and you would choose which one you are. So on the iPad-driven site, it would GIS locate you to where you are. So you wouldn't have to necessarily go through that thing. And the other thing that we don't see on this is this site here would show you exactly where you are right now. It just shows that in my office. So with every different site, it has its own checklist. So we married the checklist to the site. Oftentimes, the most visits our crews make is for the sediment forebay versus the infiltration system checklist. So we found that if we break those two things out, and they're just looking at a smaller checklist, because they're not always going into the infiltration area, typically once or twice a week, but sediment forebays, we go pre-storm, post-storm, and then 4 times a week. So a director charged with that crew will say, all right, this week we're going to these 4 places, we're going to maintain these 4 things. And when they get there, they will pull up the sediment forebay checklist, which is here. And they just go through that iPad and just indicate what it is. So debris clean out, they clear the debris, there's dumping of yard waste into the practice, and they just, indicate whatever it is and they move on. Vegetation, This is a semi-annual thing, or after a major storm, no placement of inappropriate plants, grass height not greater than 10 inches. So if that's unsatisfactory, they'll either take care of it at that time if they can, or I'll show you in a minute, this generates a report back to the director. So let's say the director is going out for lack of crew time. They go out and identify what the problems are. They create a work order. The work order goes to that crew. It's scheduled, and then they have a list of what they have to look at, what they haven't. If it's a crew member themselves and they're there to do the maintenance, they'll identify this stuff. So sediment deposits, sediment was noted. Sediment cleanout is not greater than half of the design depth. So that's the level that we use for whether the work needs to take place or if it can come back at another time. And again, so you just indicate what it is. And this is building a work order for the work to be done. Outlet, overflow, spillway, semi-annually, or again, after major storms. It's in good condition, no need for repair, no evidence of erosion, no evidence of any blockage. And then they can write in whatever comments they have. This is clogged up all the time. We're here too late. I need to do this. This is particularly important, the specificity in areas that you have. We have some terraced bioswales here, and I want to know if the sediment's making its way past the first terrace, where it is, because that talks to you about the level of function of the whole system. If we got sediment in the lowest area, we have a problem. Something else is going on. Either the infiltration area is not taking the sediment out, or whatever issues it is, we want to know. So that's where we get specific in this comment area. And then it just says what actions either need to be undertaken by a director, or they say what they did. So plant pruning, I've got to do some plant pruning here. I got to clean out the sediment. I got to do mowing, and then they either do it or don't. And then we always ask for a picture. So when you're completed, or if you're IDing something that needs to be done, right here from this screen, they can take a picture. And then that picture is embedded in the report. I'm going to show that in a second. And then they just submit it. When submitted, it generates this report. So this report says that the inspector was Leanne. It was February 26th, relatively recently. Wanted the work done by March 1st. It was the Montgomery, Cladrastis, Francis Green roundabout. We have a lot of sites here, so we have to get very specific in their location. You may not need to be that specific, and again, on the iPad, it would show exactly where it is. This is just showing me in my office. And then this is the checklist. It says, the trench or chamber or basin surface was clear of debris. That was satisfactory, and it goes down and lists what was satisfactory, what was unsatisfactory. Actions need to be taken. They're telling them to inlet clean it, outlet clean out, power brush the forebay, outflow pipe clean up, clean out sediment, tells them what to do. It mentions so these are the answers to the questions, because it doesn't say satisfactory, because these are ones that the inspector chose, contributing areas, clear of debris, dumping of yard waste, there was dumping, litter and branches have to be removed. So these were actions that the result of their evaluation. And it's in the different areas. I'm sorry I didn't show you that. So this is the sediment forebay checklist. And they move forward. It's the open channel checklist. So it indicates where this work needs to take place. Sand and organic filter checklist. And bioretention area checklist. So we've identified all these things. Some of the images I don't think are coming through on this because it's a desktop, but these big blank areas are all the pictures that Leanne took when she showed them. So they not only have it, and again, they're pulling it up on this iPad. In addition to this checklist, they also have a database of all sorts of things like what I showed in my presentation. They show a more detailed picture of that element, exactly where everything is. If they're confused about what it is, it's going to show you on that. We also use it for our snow removal crews. They'll pull up a site and it'll show exactly what sidewalks need to be shoveled. So all of this information is available to them in their iPad. We were having them do it with hard copies. It ends up on the floor of the truck. It blows out the window of the truck. You wrote your grocery store list on it. So these are real time submitted to directors, and they get reports annually through another software that we have that says, this is the amount of time we went to Cladrastis. This is the amount of work that it took. And then we build our year-to-year maintenance on that information. So there is, while these are automatically generated, there is another step for directors to compile this information manually. We're looking at another system that will do that for us, to take that out of the mix. But for the most part, this has worked extremely well for us. And it's called Survey 123, and then the information goes into a software called Green Cities. We are looking at and moving to a software called Asset Essentials. And what the difference between Green Cities and Asset Essentials is, you can build a year schedule on Asset Essentials where Green Cities we couldn't. And reoccurring things, like we even track which trash cans we empty and what their status is. So we have a larger park and there's 20 trash cans in it. Trash cans A1 is overflowing all the time. We indicate that. A25 is empty all the time. We make our workers, we help to make our workers smarter, not work harder. And so they go to A24 once every 10 days. They go to A1 every day. So we're going to do that with stormwater too. There are some sites, because of their location, that don't require as much maintenance. We were going to go there minimum 4 times a year, but those after storm things with that record, we'll know that, hey, you guys know you got to get out there. You know, it's always clogged. You got to get out there before the storm. They may not have time to do all of them. They know the hot ones they got to get to. So it's worked out very effectively for us, and it allows us to do the reporting to DEM. That DPW is actually our parent organization for that reporting to DEM. So we provide this information to DPW. DPW in turn turns it around and sends it to DEM. So we are fulfilling our MS4 permit requirement. And I think in a nutshell, that's what we have. I don't know if there's any questions related to that. I'd be glad to answer them. But it's worked very well for us, not only in stormwater, but in all elements of our maintenance throughout our 120 parks.
Yeah, there was one question, Brian. It says, how do you note when the items are done and the work order is complete? Is that in the same system?
It is. So they'll send a completed work. We also have an element where we have a start and a stop. We haven't gotten to that level of need for that, but we will, because we want to know how long it takes to do these things. So that software has the ability for you to say, all right, I'm starting the maintenance now. It clicks a time watch, you click it off, and then it sends it with a report that it took 3 workers 2 hours to do that thing. And then we apply their salaries to them. We apply the cost of the truck, the cost of the dump truck, the cost of the backhoe, whatever it is. And then we will have information on all that maintenance dollar amounts based on size. That's information that's valuable to me, and I'm sure other people. The reality is these things are so unique in what most of these panelists have said, where they are, what they are. We'll get a broad strokes idea, but I don't know you can ever get down to pennies on what these things cost, because they're all so different.
Okay, well, it doesn't look like there's any other questions. So yeah, thanks, Brian, for taking the time to do that extra bonus talk. Yeah, I think that's all we have. Thanks everybody that's still sticking around here for attending. We do have a few other trainings and events that are coming up within the next couple of months. So if you go to our website, stormwaterinnovation.org, and go to the events tab, we have a construction oversight training, and then a residential stormwater training or workshop. And then we also have our Rain Harvest Arts Festival coming up soon. So yeah, go check that out on our events page. So thank you everybody for attending today, and for the presenters for presenting. Bye.
Thank you.